Hello, welcome to the course INFO404 Advanced Object-Oriented Programming. As you can see in my slides, I will always remind of the textbook of the first part of this course, which is Core Java by Horstmann. This is a very important book about Java, and it is now in its 11th release. So every time a Java has a release, almost every time, the book updates itself. So let us begin by the inheritance chapter, and in this chapter we will have two main objectives. First, learn about inheritance and then learn about reflection. We all know what is inheritance. The basic idea is that you can create new classes built on existing classes where you can reuse, or we can say technically inherit, the methods and fields. And also we can add new methods and fields to adapt new classes to new situations. This is an essential technique in Java programming, so that's why we chose in this Master 1 class to begin with it, although I know that you already know it. So this will be a little review with additional attention to very specific and important details. So this is, as we said, an essential technique. And the other objective is to learn about reflection, which is the ability to find out more about classes and their properties during the runtime of the program. So this is powerful but complex feature of greater interest to tool builders and not to application programmers. So we will try our best to stay away from reflection as long as we can, as much as we can. But here in this chapter, we will mention reflection and we will understand what reflection is, because there are sometimes we use it without even knowing that this is reflection. So you have to know what reflection is. So the chapter outline is divided as the following. Sections are as follow. We will start by explaining what classes, superclasses, and subclasses are. Then we will talk in detail about the object Cosmic Superclass, how to override its methods, and what are the contracts you must sign in order to override the methods of object. And we will have a small appetizer about the two chapters we will see later, which are genericity and collection. Here only we will see how to use generic array lists. So this is small. We will mention and explain later object wrappers and autoboxing and methods with variable numbers of parameters, as well as enumeration classes. We will, before we end the chapter, we will see reflection. We will try to be short on reflection, and so for interested readers, they can consult the textbook, which is the Core Java, to read more in detail about this technique. And we will end the chapter with design hints for inheritance. So let us begin the section class, superclass, and subclasses, and let us consider the employee class example. Check this employee class example in the Core Java 11 code given to you, and you will see the following class employee. We have the class employee, and let us check it here in the outline. It has 3 fields. They are all of them private: name of type string, salary of type double, and hire day of type local date. We will back to this in a second. Employee constructor takes a string, a double, and 3 integers for the year, month, and day. And it has 3 accessors, which are getName, getSalary, and getHireDay. And it has a raised salary, which is a mutator. It takes a double, and then it multiplies this by percent with the salary in order to raise the salary by a certain percent. So it makes double raise equal salary times by percent over 100, and then salary plus equal raise. So let us first consider this example. So let us see whether what is the variable hire day. Hire day is a variable of type local date. If we If we open the documentation of local date, we will see that it is of the module Java base of the package Java time, and this is a final class. This is a final class, and it is a class that is immutable. So this you can read here. Local date is an immutable date time object that represents a date, often viewed as a year, month, day. So other date fields such as day of year, day of week, day of year can be also accessed. For example, 2nd October 2007 can be stored in a local date. So this type is used instead of date because in as you have already read in the book, the type date is used to represent the point in time, regardless of what this point in milliseconds means. So if whether it means 1st of October or 1st of Ramadan or a Chinese calendar. So here we are using a Gregorian calendar type called local date, which will represent the name of this date. So now that we know that local date is an immutable class, we can understand more how safely we returned higher day reference to the accessor getHigherDay method. Inside the getHigherDay method, we didn't even clone the higher day object. We returned directly the reference instance field to the caller. So this is safe because local date class is an immutable class. So even if you got the reference to the object, you cannot change the content of the object. Okay, so we are safe. Let's go back to our example and let us read the addition to this example. So now we discovered that we need to add a new class, the manager class, and add some functionality to this specific employee type. We can retain some of the already programmed which are already in the class employee because there is an obvious a relationship between manager and employee. What does this mean? This means this is an inheritance. How can I express that to be sure? I say the sentence, a manager is an employee. So does my sentence sounds logic? Does my sentence sound logic? Yes, it does. Every manager is an employee. So this is an inheritance, and I can then say that the class manager extends employee. Inside the curly braces, I add the methods and fields, if any. And of course, there will be, since I am extending the class. Otherwise, I would not extend the class, I would just use the class employee. As keywords, as terms, we will be using the term superclass or base class or parent class to refer to the superclass employee, and by opposition, the class manager will be the subclass, the derived class, or the child class. Okay, it's not just because the subclass is named subclass, it is inferior to the employee. No, this is quite the opposite. The subclass have more functionalities than their superclasses because we extend them. The subclasses extend the superclasses and they define more specific methods and fields. So, manager class will encapsulate more data and have more functionality than its superclass employee. Back to the code and let's open the manager class of the book example and let's examine together the field bonus and the field and the method, the public method set bonus, which deals with the bonus. As you can see here in the hierarchy, manager is a subclass of employee, which in turn is a subclass of object. So manager class has the bonus field, instance field, has the set bonus instance field and others, and also enjoys benefiting from all the subclasses fields and methods. So this is the inheritance. It inherits the features of its superclasses. Manager extends employee, so manager class has new field to store bonus and method to set it. As we have seen, it can use methods also get name, get hire day, inherited from employee superclass, and the fields, all the fields, they are here inside her. And every manager object now has 4 fields: the name, the salary, the hire day, and the bonus. When designing classes, you have to be sure to place most general methods into superclass and more specific methods into subclass. We arrive at the title overriding, and now not only we have to inherit the existent features inside employee, not only we want to add new methods and fields inside manager, but we want to change the behavior of some features, of some inherited features. Some of the superclass methods are not appropriate for the subclass, especially the method getSalary. GetSalary inside employee will return, as you can see, will return the salary. But inside manager class, we all know that a manager has now a bonus, and this is not fair to not mention the bonus along with the salary of the employee. So here we should override this method in order to reflect that it overrides the getSalary method inside employee in order to mention the bonus. So let us try to return the salary now plus the bonus. As you can all deduce, this is not possible. Why? Because the salary, as the compiler is showing us, the salary is not visible inside the class manager. But we have said that the salary is a field of the class of any object of type manager. Yes, it is a field, but it cannot be accessed directly. Why? Again, because it is a private field inside the class employee. What is the solution to access private fields and private methods inside any class? There is no solution unless it's from the same class itself. You only can access the interface of the class. What do I mean by the interface? I mean you can only access what is public or what is protected if we are inside the same package or inside a subclass. So back to our manager class, while overriding the getSalary method, we cannot access the salary. So maybe we can access the getSalary method because it is a public method. So also here this will not work, and I will show you that this is almost an infinite loop. So if we add here a public static void main function in which we create a variable m that refers to a new object manager, which is Cracker, born in 15 December 87 with a basic salary of $80,000 per year, and then we set a bonus of 5,000, and then we print the getSalary method. Let's try to run this example. As you can see, there are some red lines due to an exception inside the thread main due to a Stack Overflow error. This Stack Overflow error is obvious because the getSalary method is a recursive method that calls itself endlessly without a base case. So this is wrong here, and the right correction, as you all can remember now, is to call the method getSalary but of the employee class. How do I indicate this to the compiler? I add the keyword super. So I say super.getSalary plus getBonus, and then I can run and I can get what I expect to get as the basic salary plus the bonus. So this is about overriding and about the keyword super. And let's talk now about the subclass constructors. Manager constructor that we already used now, but we didn't see how, also cannot access private fields, and in order to initiate the strings n and s and year and month and day, which are all private for the class employee, must use the keyword super. And in this keyword now, it is not using the invoker of the superclass. It is invoking the super by itself. It is invoking the constructor of the class employee. So some things you must know about the keyword super. The keyword super has different meaning. It calls the constructor of the superclass with n as year, month, day as parameters. It calls using super must be the first statement in the subclass constructor, and if no super class call, if there is no keyword super inside the subclass constructor, a default one, which is super parenthesis empty with no parameter constructor of superclass is invoked, and if no, here is the danger. If no superclass default constructor exists, just like this example, inside employee, as you can see, there is no inside employee. Let's click on employee. We have only one constructor, as you can see, and it is not the default constructor. It is a constructor with 4 parameters. So in this case, and if in case we didn't put this explicit super call, and superclass constructor does not call another superclass constructor explicitly, there will be a compiler error. And another thing, the construction parameters are either passed to another constructor of the same class using this, or to a constructor of superclass using super. So here, let's see the manager class. This is the constructor. You can see that there is a super keyword here, a super call to the constructor. If I remove it, directly the compiler will complain. It will tell me that, let's see what's telling me. Implicit super constructor employee parenthesis empty is undefined. You must explicitly invoke another constructor. So he obliges me to invoke either this or super. Since I don't have any other constructor in this method, in this class, I have to invoke the super constructor, the adequate super constructor. So this was about the constructor, and now let us see what is the effect of overriding. Due to overriding, now I can create the manager boss. I just created a few lines ago. A car cracker with its salary and the birth date, the hire day, and the bonus, and then I can write the following. So as you can see here, I created the variable boss, the object reference boss, then I created the object of type manager, which is the instance of type manager, and I said the object variable boss refers to this object of type manager, okay, and then I also set the bonus just as I did before, and then I created an array of 3 employees, var staff equal new employee of 3. Now, the thing is here, staff of 0, inside staff of 0, I didn't create a new object, I only copied the reference of the object just created before. So staff of 0 and boss both share the same pointee. Both share the reference to the same object, which is a new manager car cracker. Staff of 1, I have another employee, new employee Harry Hacker, and staff of 2, I have an employee called Tommy Tester. The beautiful thing now is that when I will run this program, I will get the adequate salary for each of the employees, and that due to polymorphism, when we will arrive to staff of 1, it will not only print the salary $80,000, it will print also the bonus added to it, and this is due to overriding. So let us see before that. So this is what I mean. How did we do that? Knowing that in the for loop, I said for loop employee E. So E here is of type employee, and then inside E I said system.out.println name plus E.getName salary plus E.get salary. So it gets the name of every employee and the salary of every employee, knowing that E is of declared type employee, but at the first iteration of this array, it was of actual type manager. Here I am introducing two keywords, declared type and actual type, and we will understand them. But first, you understand what happened in the example. Let's revisit what is the declared type and what is the actual type. We talk about declared types when it concerns object variables. When it concerns objects themselves are created using the new keyword accompanying the constructor. So objects are constructed. Construction is at runtime. Declaration is at compile time. Here, for example, I declare a variable E, and E inside this for loop will reference one by one the 3 elements of the array. Those 3 elements of the array, the first one is of actual type manager, the second 2 are of actual type employee. So in the example, the declared type of E is employee. The actual type of the object to which E refers can be either employee or manager. Why? Because the employee variable can reference either an object variable of type manager or an object instance, or an object or an instance of type manager or employee. So the virtual machine knows about the actual type of the object. Why? Because the object was created using a constructor, and the constructor precised which object was creating, to which E refers, and can invoke the correct method. What are we talking about here? We are talking about the correct method of E.salary, because we know that the getSalary was overridden inside manager and it was first defined inside employee. So here we are explaining what happened inside the for loop so that each time the virtual machine guessed which getSalary it has to execute. So now we explained what is the declared and what is the actual type, and we will say that polymorphism is when an object variable can refer to multiple actual types. The case of E in our example, it referred to employee object type and to manager object type. What is dynamic binding then? Dynamic binding is the operation to automatically select the appropriate method at runtime. Let us see what is inheritance hierarchy before explaining the dynamic binding. As you can now know, the inheritance need not stop at deriving one layer of class. First, in this example, we had the employee, then we had manager extended employee. We can have also executive class, which extends an ordinary manager. An executive manager is a manager, but a special kind of managers. So this is called inheritance hierarchy. What is inheritance hierarchy? It is the collection of all classes extending from a common superclass. So this is the employee, the manager, secretary, programmer, executive are all called inheritance hierarchy. What is an inheritance chain then? An inheritance chain is the path from a particular class to its ancestor in inheritance hierarchy. For example, the path from executive to its ancestor to its ancestors in a particular hierarchy. From down to up, it is called inheritance chain. From up, all the tree down, all the set down, it is called inheritance hierarchy. So, for example, we can have a programmer, we can have a secretary class that extends the employee class, but they have nothing to do with the manager class. There is no such thing as sister class. There is no sister class, no brother class. A secretary and manager classes are both subclasses of employee, but they have nothing to do with each other. What do I mean nothing to do with each other? I mean I cannot have an object variable called manager M and let this manager M equal new secretary. The compiler will not accept. There is no inheritance chain between manager and secretary. So let us continue and continue about polymorphism. Now we know about polymorphism. We must say that Java does not support multiple inheritance. To recover that, if you have two subtypes, you want to be part of two subtypes. If you have two supertypes and you want to be part of two supertypes, you use one supertype as your parent class and the other as you don't have a choice. You have to choose an interface. We discussed this in the exercise session. So before you choose your class to extend a superclass, you must be sure this is the right superclass because it is a unique extension. The inheritance here cannot be replaced later. So you must ask yourself, is the inheritance the right design? Do I apply the is a rule in a proper manner? So here yes, every manager is an employee. This is called the substitution principle. You can use a subclass object whenever expecting a superclass object. Whenever someone tells you an employee does the job A, send me an employee in order to execute the job A, you can send him a manager because the manager object has all the features that an employee object has. So a manager can replace an employee. A manager is an employee. So you can assign a subclass object to a superclass variable, and here is the proper code. You declare employee E. So here the declared type of the variable E is employee. You can either write E equal new employee blah blah blah, or write E equal new manager blah blah blah. Both are okay. And this is called polymorphism. This is polymorphism. Object variables are polymorphic. Okay, here E is an object variable and E is polymorphic. It can hold either the declared type, either an object of the same declared type, or an object of a subtype of this declared type. So inside listing 5-1, we just saw it. We saw the variable E, and we saw it can hold the declared verb manager and the declared type, the actual type employee. Sorry. If I say staff of 0 dot set bonus 5,000. Now I have said already boss dot set bonus 5,000 and the compiler didn't object. Everything went smoothly. Now if I say, for example, staff of 0, which is of declared type what? Which is of deduced declared type employee, because I said this is a new array of type employee. So just just let's try here to write the following. Staff of 0 dot, and let me show you there is no dot set bonus in the options. If I say set bonus, because you say maybe the compiler doesn't know, but we already know that staff of 0 refers to the object manager car cracker, so I can do set bonus now, and I change the bonus from 5,000 to 6,000, for example, or to keep it like it was, but the compiler doesn't understand this. The method setBonusInt is undefined for the type employee. This is very important. For the compiler, you know, the process is the following: compilation, then run. It doesn't pass the compiler, so it cannot be executed. This is the rule. If the compiler sees the staff of 0 staff in general is of type employee, any invoked method over the object's reference to by staff of 0 must be declared inside employee. So what does the compiler do? It goes to the employee class. It finds, is there any set bonus here between the methods of the employee class? No, there isn't. So it won't allow this instruction to run. So let us say wrong here. But what can go bad? Now the delicate thing. Caution with arrays. Let us consider we have an array of managers and we created it new managers, and another array staff equal managers, okay, declared as being an employee array, an array of employees. Something surprising will be going on. If I say staff of 0 equal new employee, what do you think will happen? Do you think the compiler will allow this? Let me check with you. So here I have my example. Let me add to this example manager, okay, manager array managers equal new manager of supposedly 10 managers, okay, and here employee array, I will call it staff 2 because we already used the array staff. And here, instead of creating a new employee, a new array, I am referring to the same created array as managers. So I will just say it is the same array. So those are two names, two variables referring to the same object equal managers. Did the compiler accept this truth? Yes, it accepted. No errors here. And then what did we say? We say staff of 0 equal new employee. We say staff 2 of 0 and equal new employee. Blah, blah, blah. Let's copy this. We just saw before that if a variable of type manager cannot hold an object of type employee, so why shall this happen? Staff of 0 is a variable of type employee, okay? It can hold an object of type employee, but the reality is that staff of 0 as an object and a 10 array object, each of which is a variable reference to a manager. So the declared type here of each of the 10 elements, the declared type is a manager, because you know here this is a special declaration to a new array of type managers, and it doesn't hold any elements yet. Okay, so what happens here? What happens is that the compiler accepts this. What does it mean? This means that staff of 0 or staff2 of 0 and manager of 0 are a same reference. They point to the same object. So now what we have Harry Hacker inside the array managers. It's the first element of the array managers. What does it mean again? It means you managed to smuggle a mere employee into the management ranks. So what if I say now Harry Hacker is inside the array managers? What if I say manager of 0, which is Harry Hacker, which is in fact an employee, dot set bonus? He is an employee, he does not have a bonus. Now I am saying set him a bonus of $4,000, and the compiler is not complaining. What do you think will happen? Let's see. Let's see what will happen. Run. Something red appeared on the screen. Exception in thread main. But this time, which kind of exception happened? Array store exception. Okay. Inheritance.employee at Kojava, etc. So this is an array store exception. Why? Because there is no such thing as bonus inside the first element of the array. So managers of 0.setBonus would try to access a non-existent instance field and would corrupt neighboring memory. It would do this. Did it do inside Java? Did we put 4,000 in some memory? No, we didn't. The Java virtual machine resisted to this attempt. To make sure no such corruption can occur, all arrays remember the element type with which they were created. It's true that staff of 0 and managers are both arrays, but who really created the arrays? New manager of 10. So the arrays remember who created them. They remember that they are really of type manager. The elements of the array are of type manager. So what they do, attempting to store an employee reference causes array store exception. So from where did this exception went? Did I cause this exception at line 33 or at line 32? Look with me, it's from line 32. So here is the problem. The problem was to prevent the set bonus. So this is an exception. So this is a runtime error, not compile time error, but this didn't damage the memory of the program. To override a method, you need to define a method in a subclass that has the same signature as a superclass. By signature, we mean not the return type, we mean the name of the method, and we mean the list of parameters. For example, here getBody and the list of parameters, no parameters. This is called also overriding. So you need to keep also the return type compatible. How does it work this way? GetBody, for example, this method tells you who is the body of who. So m.getBody tells you who is the best friend of m. e.getBody, he will tell you who is the best friend of e. So here you can say that public employee getBody inside the employee class, and inside the manager class you can declare override getBody by saying public employee getBody. but really it is not necessary to keep the same return type. It must be at least compatible. So anyone expecting an employee return value would easily accept a manager object, because this is also polymorphism. This is what we said about polymorphic object variables. So these two getBuddy methods have covariant return type, and yes, the second getBuddy overrides the first. So overwriting method must have at least as visible as superclass, must be at least as visible as superclass. If the getBuddy of the employee class was public, the getBuddy of the manager class must be public. So suppose here I have inside the employee class, I declared public employee and whatever, suppose return null. Now nobody cares about the implementation. If I say this and I want to override this fact inside the manager class, public employee getBuddy also, okay, this is formatted now. Look, the compiler accepts that. Okay, this is overriding. If I mention overriding, he will not say that no, this is not overriding, this is overriding. If I say the return type will be manager inside the manager class, also this is overriding. But when I remove the public keyword, the compiler will not be happy. Multiple markers at this line cannot reduce, look, cannot reduce the visibility of the inherited method from employee, and it overrides the inheritance employee.getBuddy. You cannot override it and lower the visibility. It must be at least as visible as the overridden method. So because inside employee it was getBuddy, where is getBuddy inside employee? It was public, it can only be public inside the manager. If inside employee I put it protected, okay, getBuddy, inside manager I can still keep it public because this is bigger than protected. Okay, you can raise the visibility, you can keep the visibility as is, but you cannot lower the visibility. You cannot say it becomes now private, for example. The compiler will quickly get angry. You cannot reduce the visibility of the inherited method from employee. Okay. So common errors are what? Common errors are when you accidentally omit public for subclass method and the compiler complains about the weaker access privilege. Look, for example, you accidentally remove this, and this is what I showed you. So let's now resume and talk about dynamic binding. When a method call is applied to an object, what happens in order? First, the compiler looks at the declared type of the object and method name. He sees the object is X. What is the declared type of X? Suppose it is the class C. Okay. Then he looks. What is the invoked method name? F. Okay. Compiler goes and enumerates all the methods called F where inside the class C, and all the public methods called F in the superclasses of C. He sees if there is an F from C and above. Okay? If he did, and then the compiler determines, second, The types of parameters applied in the method call, because you all know about overloading. Maybe there is a function, there is a method called f, but that does not take the parameters needed. So, between the parameters that I am searching for, if the choice is unique, if a unique method best matches the choice, so this method is chosen to be called. Attention, even if this method is overridden in an actual subtype, the compiler doesn't care about the actual type. He doesn't see the actual type. Else, if the compiler does not determine which method to choose between the overloaded methods, the compiler reports an error and he will say overloading resolution. I found some adequate methods, but I cannot determine which one of which parameters I have to choose. Okay? Third, if the method is private or static or final, or if this is a constructor that is being invoked, this is called static binding. This is not dynamic binding. Otherwise, this is called static binding. We statically link this method to the call. So in the virtual machine later, when we execute, this method will be invoked. And otherwise, the compiler at least has one method in hand, but he doesn't know if this method will be executed or an overriding method. So otherwise, this depends on the actual type of the implicit parameter, and this is called dynamic binding. What is dynamic binding? It is when the program runs and uses the dynamic binding to call a method. What happens? The virtual machine must call the appropriate version of the method for the actual type. The actual type, for example, is D, just like manager and getSalary. The declared type was employee, but the actual type was manager. Inside employee, there is the method getSalary, but when the virtual machine runs, it finds another getSalary method inside the actual type D that overrides the initial getSalary. So if class D defines a method called f of string, for example, if this f of string at the first place, that method is called. If D's superclass is searched, else D's superclass is searched for a method. So we go from D, for example, this is C, and this is D, and between C and D there is a chain, and before C there is a chain. The compiler will search for C and above for the function, for the method. He chooses the method. At runtime, the virtual machine begins searching from D until C and above. So whenever it finds an overriding method, it begins from D. If it doesn't find, it begins from the class between D and C, and so on until it reaches, at the worst case, the method that the compiler chose for her to be executed. So, as an example, the Java virtual machine method table was the following. The virtual machine has the method tables for the employee and manager classes. For example, the virtual machine knows that if anybody calls getName, it will be from employee, it will be executed from the employee classes. But for manager, if you call getMain, it will execute the one inside employee also, because there is no getName inside the manager class. But for example, the getSalary, for the employee class, it will be executed, but for the manager class, okay, for the manager actual type, whenever they will call getSalary, it will execute the getSalary of the manager. And set bonus is inside the manager, and inside employee there is no set bonus at all, etc., etc. So, getSalary at the runtime. First, the virtual machine fetches the method table for the actual type of E. It may be a table for employee, manager, or another subclass of employee. Then the virtual machine looks up defining class for getSalary signature and knows which method to call, and finally it calls the method. What is the dynamic binding most important property? The dynamic binding has a very important property. It makes the programs extensible without the need for modifying existing code. What does it mean? It means suppose we add later, after we have written, compiled, and prepared our classes. If later, after compiling, we write the executive class and we added and there is three possibilities that the variable e refers to an object of that class. Suppose inside the for loop there is for loop, just like we did before here. Let me show you. As you can see, this is the employee class, this is the manager class, this is the manager task class. The manager task class, suppose it is also compiled. And after that, I add the executive class, in which I have overridden also the getSalary class. And inside the manager class, I have, for example, the for loop that refers to an executive object. What happens? Since this is the virtual machine job to invoke the correct, to do the dynamic binding, the code containing a call to e.getSalary need not be recompiled. The executive.getSalary method is called automatically if e happens to refer an object of type executive. What shall I explain here? I shall explain that this for loop can be more complex. Maybe this for loop for employee E inside staff, maybe the staff is not defined here. Maybe the staff is given into as a function argument, okay? We are not inside main, we are inside another public static void function, and it takes the staff as an argument. And this code is already compiled. And even if the employee array has now one of the elements actual is executive, knowing that this code has already been compiled, it will work, and the dynamic binding will work because it is the runtime job. Preventing inheritance, we will talk about final classes and final methods. In order to prevent someone from forming a subclass from one class, use the final modifier. Final class executive extends manager. For example, you can make a method in a class final, only one method. For example, inside the class employee, you can declare the method getName to be final. Why do we do that? We make a class final. Maybe we don't want any other class to extend it. We are afraid that if another class extends our class, it will change its behavior, it will mess with our methods, it will override our methods and change the spirit of our class. Also, the same logic applies to some methods in the class and not all the class. So you can extend the employee class, but you don't really need to override the getName, since the getName refers to the name and the name is private. So what will you use the overriding of getName for? In order to make sure nobody messes with my method, especially if my thinking is no need to override, I can declare it final. This is very important. So final class or method is made to make sure that the semantics cannot be changed in a subclass. For example, in the class calendar, the getTime and the setTime are final. Why? Because the class calendar, let us see it inside the Java doc. The class calendar is an abstract class, public abstract class calendar. So it cannot be instantiated itself. You have to use one of the subclasses of calendar, yes, but you don't need to override the method what did we say? It was the methods getTime and setTime. So let us see the methods getTime and setTime. inside calendar. So this is get time. It is final. Okay, you don't need to override it. In order to make sure nobody extends calendar and messes with this very delicate detail, it is made final. So it is a good idea to think carefully about final methods and classes when you design a class hierarchy. This is not arbitrary. You don't say, okay, let's leave it now. We don't think about it. When you are designing a hierarchy, you must think of every detail, of every feature. Do I make it public or not? Do I make it static or not? Do I make it final or not? This is very important. If you think nobody will need it, nobody have to change it, you must make it final because it's like you are protecting your features. Now we arrive at casting, and we must say, for example, just like casting between primitive types, you can convert an object reference from one class to another. It's the opposite of polymorphism. The polymorphism is implicit. You can easily put a manager object inside an employee object reference. But the opposite, if you have managers, new manager, and a staff, which is an array of employees, to refer managers, and then you say manager boss equal manager cast to manager the staff of 0. And you know very well that inside staff of 0 there is a manager object because the initial type of manager is of staff is of type manager. As you can see, manager is the real type. Manager is the real type of the array, of the elements in the array staff, because employee staff equal managers. If I write this, will it work, yes or no? Let us try. So let us consider this example, which I modified a little bit. Here I created a manager, and then I set the bonus, and then I created the array of managers, and then I refer to it by also the array of employees, which is of 10, let's say. Also, the array of employees, which is referring to the same array of managers. Okay, let's say that. And then I say managers. Okay. And then I say staff of 0 equal m. This is very logic. Staff of 0. Staff is an array of employees. Let's say employee. Okay. So an employee variable can refer to an manager object. Okay, until now this is good. So far so good. And then I say, for example, I remove this. Manager boss equal staff of 0. Where is the problem? Why did the compiler tell me type mismatch cannot convert from employee to manager? This is the compiler, guys. The compiler does not understand that inside staff of 0 there is an object of type manager. The compiler only talks about declared types. So the declared type of staff of 0 is employee. Even if there is a manager inside, he does not care. The compiler likes to stay on the safe side. So for him, you are trying to store the reference of an employee inside an object variable of declared type manager. This won't happen. If you as a programmer are sure that there is a manager, you can explicitly cast. You can say, please cast on my responsibility. This is a manager, so cast it to manager and put it inside boss. So in this case, he will accept, and we will run and see that everything will go right. And he will calculate the salary because in fact Cracker is a manager. But what if there isn't Suppose that I am casting and I am lying. Let us continue. So here is the explanation. You can make a cast to use an object in its full capacity after its actual type has been temporarily forgotten. You need to cast managerial element of an array back to manager to access any of its new variables. So staff of I refers to an employee object, so it can also refer to a manager object. If there is, you cannot cast anything. You cannot cast here, for example, let's say string. Just because this is a technique, you use it in a non-logic way. You cannot say, for example, a string s equal cast staff of 0 to string, because the compiler will not be convinced. He will tell you boss cannot be reserved to a variable. Sorry, boss here. Okay, I will remove this boss. Okay. Now, cannot cast from employee to string, not just because you can use the two parentheses that you can cast. Okay, so let's make undos until we reach our stable version. And now, what if I told you another thing? What if I told you that in fact, employee staff is a new employee array, is not at all in relationship with manager. What if I say employee staff is a new employee array of 10 elements, and that staff of 0 is not no, is new employee of, let's take from the old test this one, new employee, blah blah blah, Tommy tester with a salary of 4,000. Okay, and now I continue normally. Manager boss equal cast staff of 0 to manager. Look with me the danger here. What will happen in your way? We just explained that if there is a chance that it will succeed, the compiler will not object. Here the compiler didn't object. Okay, so let's remove this variable, or let's comment it. We don't need it in my example right now. What do you think will happen? Let's see. Okay, here nothing will happen, but let's try to set bonus now. Boss dot, you can set a bonus because set bonus exists in the variable. Set bonus 3,000. What do you think will happen? Staff of 0 contains an employee. It does not have any bonus, and you cast it, and now you are trying to set a bonus. What will happen at your opinion? Proceed. Exception in thread main, line 23. So here there is an exception even if you didn't try to set the bonus. Class inheritance employee cannot be cast to class inheritance.manager and are not it cannot be casted because at runtime they know the actual type, and the actual type was employee here, so it cannot be converted. So even if you don't write this line, the exception will still be here. Okay, the exception will still be here, and this is the difference between an error on the compile time and an error in the runtime. Here, this is a kind of reflection. You are casting by force. You are saying on my responsibility, and you are lying, and this is the result of your lying. You got an exception. You got a runtime exception. A runtime exception is something bad, of course, because a compile time exception, you didn't compile, you didn't sell your code yet. But when you compile and you test and you sell your code and the client finds a runtime exception, this is so bad. Okay, so So what happens, we continue reading, what happens if you try to cast down an inheritance chain and you are lying about what the object contains? For example, the example we said, when a program runs, Java runtime system notices this broken promise and generates a class cast exception. If no exception cast, if there is no catch for this exception, just like our program, we didn't catch the exception, we didn't put it in try catch, the program will terminate. Okay, so what is the solution? If I am not sure whether there is an actual type manager or actual type, suppose this line is not here, suppose this line is somewhere else. Suppose the following line is elsewhere. It means we received the variable stuff of 0. We received something of type employee, declared type employee, and really we didn't know really whether manager, whether this employee is of actual type manager or employee. What do? Before you cast, always before you cast, you put an if and you test about the actual type. How you test about the actual type? This is also called a reflection, the instance of. You say if staff of 0 is really an instance of, without is instance of manager, then cast to manager. Else don't cast to manager, please don't make me troubles. Okay, so let us, what is the problem here now? Manager cannot be reserved to a variable. Manager okay, this is an if statement, so let us put everything inside the if statement, because outside this if statement there is no something called boss. So the system.out will object, of course. Okay, now we should have no problems executing this, and we should not also get a runtime error. So here is our runtime error. Nothing happens, nothing is executed, because in fact staff of 0 is not an instance of manager. We are on the safe side. We didn't make problems. We didn't get a class cast exception. We didn't give broken promise to the compiler. I only converted to manager when it was really a manager object. Okay, so this is the use of instance of here. If really it is an instance of manager, because its declared type is employee. But if it happens to be a manager, so please cast it to manager so that I, for example, get the salary really. Okay, so this is the thing here. So no cast permitted if no chance to succeed. We explained that, and you can cast only within an inheritance hierarchy. In general, it is best to minimize the use of cast and the instance of operators, because those are reflections. So let's talk about abstract classes now. Up in the inheritance hierarchy, if we go up instead of going down, classes become more and more general and abstract. Let's say that an employee is a person, in fact, so is a student. So if we have a type student and a type employee, let's define a supertype person from which both types can inherit. So let's extend this class hierarchy and include the class person and student. Both students and employees have names. So what about the field name? Do we keep it inside the class employee, or we factorize it into the class person? So you can introduce a superclass and you factor out get name to higher level. Get name and name, of course. So this is the abstract class person, and you can see it can have also a get description. Every person you can describe it. So now, since we didn't mention yet the toString method of the class object. So suppose the get description will return a brief description of the person. If this person is an employee, it must say, for example, an employee with a salary of this much. If this is a student, it must say a student majoring in this major, etc. So it is easy to implement for employee and student, but what about person? We said every person can have a description, but it is not easy to implement the person.getDescription method. So you have to choose either to implement this getDescription method to dummy implementation, let it return an empty string or something, or to use an abstract keyword, which is the proper manner to do. So if at a certain level you cannot implement a method, you just leave it abstract. For added clarity, a class with abstract methods must itself be declared abstract. So we declare it here abstract before the name of the class. So this is our class person because we have an abstract method inside it, even if only one. The class itself must be abstract. If I remove the keyword abstract, the compiler will tell me the type person must be an abstract class to define abstract method. So I click and I say make the type person abstract. Abstract classes can have fields and concrete methods, and this is a very important remark. Abstract classes, not because they are abstract, they have to be all the methods inside must be abstract. Okay, so to extend an abstract class, you have two choices, either to leave some or all of the abstract methods undefined, and then the extending class must by its turn stay abstract, or when you define all the methods, you can remove the keyword abstract from the class declaration. Abstract classes cannot be instantiated. Okay, so let's go back here in our example and let's put a public static void main inside this. We can always put inside a public class a public static void main for class testing. Okay, even if you have a test class, you can still have your own main inside each class in order to test this class particularly. Okay, and you can run. So if I have now declared a person P, there is nothing wrong when you declare an object variable of type person, even if this type is abstract. But the wrong thing, that's why I'm separating the two, the declaration and the initialization, is if you say P equal new person. P equal new person will make the compiler very mad. He will tell you you cannot instantiate the type person. Okay, so this is wrong. Not possible. Object variable of an abstract class but refer to object of a non-abstract class. You can say here, for example, P equal new employee. Yes, new employee, yes, but new person, no. And this is, of course, polymorphism. So we continue our example. You can fill an array of person references with employees and student objects. For example, let's take inside this is the test to delete, this is the person test. you can have an array called people of type person and of length 2, and the first element of this array you can put an employee, and the second element you can put a student, which is very, very logical. And then you can iterate over this array in order to print the name and the description. As I already explained to you, this is possible because the name and the description. What is the declared type of P? The declared type of P is person. So we go to the person hierarchy. Sorry. We go to the person hierarchy and we see whether there is inside person, we double click on person, whether there is get name and there get description. There is, so we can easily invoke those methods. So the question here, if I have omitted the abstract method from person superclass, I could not invoke the get description on variable B. Explain. If inside the class person you say, why do we need to declare this get description method since it does nothing? So I say, yes, you're right, let us remove it. We go to person test, and here you see that a person people system.out.println, we have the get name, it's okay because the declared type of P is person and it has get name. And again we go to person and let us open F4, the hierarchy. This is person, and in person we don't have get description anymore. And when we don't have get description anymore, of course the compiler will protest and he will say the method get description is undefined for the type person. I cannot discuss with the compiler. I cannot tell him, please baby compiler, look at me. People of 0 has new employee and an employee already has a get description look, and people of 1 also has an object of type student, and also the type student has get description. So why do you protest? Please go ahead, continue your work. He will not accept. He wants the declared type of the variable to have get description. So this is the purpose of get description. Even if it is abstract, it is very, very important for the polymorphic job, for the polymorphism. So I will paste it again here, and I will save all the job. Back to our so let's deduce that abstract methods are very important. Let's discuss the protected access now. Discuss protected access, and let's read the following very important information about protected access. So in general, as a rule, fields are best tagged as private. Some of the methods are, or most part of the methods are best tagged as public, and sensitive and internal use methods must be tagged as private. And let's see what must be tagged as protected. When they are declared as private, so fields will not be visible to other classes, okay? So a subclass cannot access a private field of a superclass, and this was the case of the field salary. We cannot access it from the class manager. So to restrict a feature to subclasses only, sometimes, some rare times, you have a feature that must be accessed by the subclasses. A feature, by feature I mean either a method or a field. So in order to let the subclasses, to let the children classes access this feature, you can declare it as protected. But to declare it as protected, for example, the superclass employee, if it declares hire day field as protected, then the manager method can access it directly. Okay? So let us go to the example of inheritance, because here we don't have a manager. we go to the inheritance example and we see the employee class. Let us close the others. Okay, and we open the manager class, and let me open the manager test2 class. Okay, inside the employee class, if I declare the hire day as protected, then the manager class can see. However, there is no way that the manager class can peek inside the hire day field of an employee object. It can only peek inside the hire day field of a manager object, even if the hire day field is protected. But try to figure out a scenario in which the manager class sneak inside the hire day field of employee object. You cannot. So I found a very tricky way to explain to you the sentence in red, because it imports very much to it is very important to understand the sentence. However, manager class methods can peek inside higher day fields of manager objects only, not of other employee objects. So I prepared this example for you. Where are we? We are inside the package inheritance. We have the class employee. Inside the class employee, as you can see, as you know, we made the higher day field as protected. Okay, so now the class manager, since it is a subclass of employee, it can access and modify and everything about the field higher day. But what is the sentence in red saying? It says it can modify her own field and not those of the employee objects. So I prepared this example. We are inside public static void main inside the class manager, and we are saying var m equal new manager car cracker, and then we access directly higher day from inside the public static void main. Yes, we can, because this main function, this main method, is inside the manager class. Even if it is static, yes, you can access private and protected and public, of course, fields and method, because it is inside the class. So for a certain object manager of type manager reference to by an object variable m, focus here because this is very important. I can set the higher day to, for example, local date dot now. Now is a static method inside the class local date. I can even, and this is very important to focus on, create a new employee and change the hire day of this employee. But this is not what the sentence says. This is because the protected keyword means that the feature can be seen by the classes, by the subclasses, and also by the classes that are in the same packages. So what shall I do now? So this is very this is nothing wrong about this code. What I will want you to know, if I move the class manager inside another package, outside the package inheritance, inside another package, now I have a problem with what I have written. Manager can always modify the higher day field of the object of type manager, but since it is outside the package, this only relies on the extension of employee, so it can extend employee. It can modify higher day, which is an instance field of the class employee, but now it cannot modify it for the objects of type employee. It can modify them for the objects of type manager only. And you can see the compiler now message the field employee.hireday is not visible. It is the same field. Inside employee, I have the hire day. Inside the employee, I have the hire day field, which is protected. There is no other hire day. But what I am showing you now is that this field, if the object of actual type manager, it can be modified. If the object is of actual type employee, it cannot be modified. If I take all this public static void main, I put it inside employee. Look, I will put it here. Okay, no problem. But if I take it and put it inside manager, there is a problem. He will tell me the higher day is not a public field, it is a protected field. It can only be modified from subclasses and from the classes in the same packages. From subclasses, if this is a subclass, just like the case here, you can modify, but you can modify only your fields, which is, this is the subclass manager. She can modify fields of the subclass manager. And this is very, very important in the security of Java, in secure coding, and this is very important. And also, you use protected fields with caution to preserve encapsulation. Okay, not just because I don't want to call the super method, I use a protected field. A class also may declare a protected method, a method protected if it's tricky to use. We will see this in detail when we explain the method clone of the object class in the next chapter. Okay, we will now explain the object class, but we will omit only the method clone. We will see in the next chapter. So please remember this explanation I have done now in order to refer to it later. Protected features in Java are visible to all subclasses as well as to all other classes in the same package. Now you know how. So protected access, use protected fields with caution. Other programmers may inherit classes from your class and can no longer change the implementation. If you have a protected field, it is not private to you anymore. It is shared with all the other subclasses. If you want to change its name, if you want to change its type, if you want to change anything, other programmers will be upset because they rely on your code. So, which is against the spirit of OOP, of course, because OOP means encapsulation, encourage data encapsulation. However, in the opposite side, you can use protected methods. That makes more sense, but you declare a method as protected if it's tricky to use. Subclasses, which presumably know their ancestor well. So a subclass, when a subclass extends its ancestor, it means it knows her, it knows what it does, what its purpose, what's the semantics behind. Can be trusted to use the method correctly, but other classes cannot. So I already have mentioned that we will see this in detail with the clone class, with the clone method. Access modifier summary, use private. This means the feature is visible only to the class. As I said, for fields, instance fields mainly, and for private methods which are used only inside this class. Nobody needs to know about them, like helper methods, methods that are very close to the internal implementation of the class. Use public when this should be visible to the world. So everything that is public will be part of the interface of this class, of the vitrine of this class. Use protected, which will be visible to the packages and all subclasses. And use nothing, omit to use a access modifier, which will be visible to the package. This is the unfortunate default. You will omit, you will forget to say something, but this means everyone in the package will see your feature, and this is no modifiers are needed. So let's explain now some special features about the object, which is the Cosmic Superclass. So next title is Object, the Cosmic Superclass. Reach the next section, which is entitled Object, the Cosmic Superclass. So here we read that object is the class that is the ultimate ancestor. Every class in Java extends object, and this sentence you can read in the documentation of object class in Java doc. Class object is the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. Let us see the methods of this class. You have clone, equals, finalize, getClass, hashCode, notify all, toString, wait with long time out in millisecond, and another wait. And only one deprecated method, which is the finalize, which means that this method is not to be used anymore. So all the other methods are inherited implicitly by all the classes in Java, including the class employee, manager, student, person, whatever class you think of, string, arrays, even array. Okay, so you can use the variable of type object to refer to any other type since it's a superclass. Like here in the example, object obj equal new employee Harry Hacker, etc. So this is only useful as a generic holder for arbitrary values and will be also useful to explain genericity and generics. Okay, to do anything specific with the value, you need to know the original type and then to cast. For example, if you want to get back, to know the salary, to get the name, you have to cast obj into employee and then assign it into the variable e, or directly invoke another method, specific method for employee. Only primitive types are not objects. This is a truth. All array types, no matter whether they are arrays of object or arrays of primitive types, are class types that extend the object class. This is a fact. So you can have an array called staff of employees. You can affect staff to the object variable. You can say obj equals staff. This is okay. Obj equal new integer 10. This is also okay. One very important method of the class object is the method equals. What does this method do? This method tests whether one object is considered equal to another object. By default, this method is implemented in the object class. So by the way, object class is not an abstract class. Object class is a concrete class. And every method inside this class is a concrete method by conclusion. So what is the implementation of the equals method? What does equals method takes and what shall it return? It is a public Boolean method called equals, which takes an object parameter and return a Boolean. It determines whether two objects references are identical by default. So this is a very reasonable default. If you have two objects and you want to compare them, you have no idea whether those two objects are two employees, 2 points, 1 point, 1 employee, 1 string, 1 array. So what shall you compare? How do you compare them? You compare them by their references, by their addresses in the memory. If both variables refer to the same address in the memory, you are considering them as identical. So this is a default equal operator. Okay, so by default, equals is nothing else but the equal operator. And this is a reasonable default. However, you will often want to implement state-based equality. What is a state-based equality? You don't compare the addresses, you compare the content. You see whether they have the same number of fields, the same type of fields, the same name of fields, and the same values of fields. So for example, let's take an example. If you consider two employees to be equal, if they have the same name and the same salary and the same hire date, you implement equals as follow. Public boolean equals, it will always take an object named other object, and then you do focus on the steps here. Focus on the steps here because you will be repeating them often. First, you do a quick test to see if the objects are identical, because if they are equal, so it means they are exactly the same object. No need to compare the state. It's necessarily the same state. So if this equals other object always equals takes one parameter, because the other is this object, is the implicit parameter. In Java programming, in object-oriented, there is always a this parameter based on which object the method is invoked. So, secondly, if they are not the same object, we continue. Must return false if the explicit parameter is null. If you compare something to null, necessarily you must return false. Third step, if the classes don't match, they can't be equal. This is an option. There are other options. So here, this is an option. You can change. We will see how later you can change. So you will invoke also here getClass is a reflection method. If this .getClass different than other object and .getClass, you will return false. Next step, if you didn't return by the first three statements, so they have the same class, the other one is not null, and they don't refer to the same object. Now we know other object is non-null employee, so you cast, you see? Because getClass replaced instanceof, so you are sure now that the casting will not lead to a broken promise. So you will cast to employee, and now you can have the other object casted into an employee variable of type other. What shall we do next? We shall test whether all the fields have identical value. Our condition that they have the same name, the same salary, and the same hire day. So you compare return name equal other dot name and salary equal other dot salary and hire day equals other dot hire day. This is not finished yet. We will improve this version, but let us first examine what we wrote. For the primitive types, we use the equal operator, and for the complex types, we use also again the equals method. And this is very important remark, because equals is everywhere. Every class has equals. Either it has the default implementation inherited implicitly from object, or it has overridden its default implementation to whatever version suits her. So every time I have to compare two objects of a certain class, I only have to invoke their equals method. This is very, very important. And if those fields are primitive types, I only compare them using the equal operator. So, the getClass returns the class of an object. We will discuss it later in this chapter, in the part 2. In test, two objects can only be equal when they belong to the same class. Okay, here we have a small tip which is very important in secure programming. When you call name.equals and when you call hireday.equals, you must watch out, and this is seen in the previous chapter of the book, that you have to invoke equals over a non-null object. If name was null and you are saying dot equals, you are invoking over a non-null variable, a null object, and this is very dangerous. It's like dereferencing a null reference, a null pointer in C. So in order to avoid this mistake, to guard against the possibility that name or hire day are null, you can use the object.equals method. What does the object.equals method? The objects.equals method. Let us search for this objects with S, not capital, sorry. The class object. Let us read about this class. This is a public final class called objects with S at the end, which extends object, of course, like all other classes. This class consists of static utility methods. There will be many static utility methods you will use in Java, just like the class math, the class arrays, the class collections with S always at the end, the class objects with S at the end, and so on. What are those classes? Those classes are tool sets. All their methods are static, all. So you don't have to instantiate those classes in order to use the methods. You only use the methods. If you want to use the method, for example, like here, equals of the class objects, you only say objects.equals. You don't have to say new objects and then equals, because this is a static method. So what is this method good for? This class good for? This class consists of static utility methods for operating on objects or checking certain conditions before operation. So this class is written by the designers in order to facilitate your life, in order to for you not to write the same code again and again. And anytime you want to see if this is null, this is not null, compare, you use objects.equals, for example. These utilities include null-safe and or null-tolerant methods for computing the hash code of an object, returning a string for an object, comparing two objects, and checking if indexes or subrange values are out of bounds. How nice! This is a new class, and this class exists since Java 7. Okay? So let us take advantage of this class and use it in our code, in our implementation of equals, and let us know that instead of invoking A equals B, that has the danger when A is null, a null object, you can invoke objects dot equal A comma B. So now you have two params inside the equals object, inside the equals method of the class objects, static of the utility class objects, which returns true if both arguments are null, false if one is null and the other is not null, and if not otherwise, it will call simply A equals B or B equals A, because no, equals AB will call A equals B, and equals BA will call B equals A. With that method, the last statement of the employee equals method becomes like that: return equals name comma other dot name, and salary equal salary, and objects dot equals hire day comma other dot hire day. So here we used objects dot equals twice. So this is ideal as a definition for equals. In subclasses, so this was the definition for equals in the employee class. What about the subclasses of employee? Suppose I have the manager class and I want to override. Now I am obliged to override the manager implementation for equals. So if you want to call equals on superclasses, if not passed, then objects cannot be equal. Then compare instance field of the subclass. So inside the equals of manager, you have to call the equals of the superclass. You have to call super.equals, because two managers cannot be decided if equals or not equals unless their super method considers them as equals, and then you will have to compare the more specific features for this subclass. Okay, a subclass is a subclass. It has a superclass. So the equal concept is not independent from its superclass. There is a relationship obliges that the equals implementation be coherent. You cannot be equal managers and the equals of employees does not agree. Then, if they are not equals on the superclass, the objects cannot be equal. If they are considered equals by the method of the superclass, then you can add additional condition to consider them equal in this subclass. Example, public boolean equals other object. If not super.equals other object, return false. If we didn't return false, this means all this method returned true, including that they have the same getClass value. If they have the same getClass value, you can easily cast them to manager. So we will say other equal manager dot class to manager the other object. And then you can continue comparing, for example, here the bonus. If they have the same bonuses, return true, else return false. Let us examine this code here in our equals package. This is the equals of objects of type employee. Here it is. I just copy paste this. And then for the manager, here's the equals of manager. And inside the class manager, it is necessary that you call the super of your class. If they are not super.equals, return false. Else cast the other object into a manager type and then return whether bonuses of this is equal to the bonus of the other. Inside this equals test.java, we have the public static void main, which uses a new employee, Alice Adams, and again affects Alice1, Alice2 to Alice1. So basically they are the same object variables referring to the same shared object of type employee. Another object of type employee is referenced to by Alice3 but with the same state, same name, same salary, same hire day. And then a third one which has different name, different salary, different hire day. And then we compare Alice1 with Alice2 with the equal operator. Then Alice1 with Alice3 with the equal operator. As you can guess, Alice1 will be equal true to Alice2, but Alice1 will not be equal to Alice3 because they are created with new employee. Alice1 is a different object in the memory, even if it has the same state. So the equals operator here will not lead to true. However, the equals method between Alice1 and Alice3 will lead to true, of course, and between Alice1 and Alice2, of course, this is the same object, but not between Alice1 and Bob, of course. Then we will see the toString, which we will explain in few minutes. So we will proceed Alice1 with Alice2 equal true, with Alice3 false, Alice1 equals to Alice3 true, and Alice1 equals to Bob false. So equality testing and inheritance for equals method, there is a contract. And if you don't believe me, just open the equals method from inside the object. Let me go back to the object class, not to the objects class, and go to the method and go to click on equals and look with me. This is very important. I want you to memorize by heart. Equals indicates whether some other object is equal to this one. The equals method implements an equivalent relation on non-null object references. It is reflexive. It is symmetric, transitive, consistent, and non-null reference. I will explain all of this in my slide, but I want you to see this in the Java doc. This is very important. Equals must have following properties. It must be reflexive. What does it mean? For any non-null reference x, x dot equals x should return true. It must be symmetric. For any references x and y, x dot equals y should be true if and only if y dot equals x is also true. It must be transitive. For any reference x, y, and z, if x equals y returns true and y equals z returns true, then x equals z should return true. It must not give me a surprising answer of false. How x equals to y and y equals to z, and then x with z, they are different. This is not logical. So this is a contract. You cannot invent your own equals just because you are inventing your own class. If you do so, you are not a good Java programmer. You are nothing. It is consistent. It must be consistent. If the objects to which x and y refer haven't changed, then repeated calls to x equals y return the same value. It must not be arbitrary. It means sometimes it returns true and sometimes it returns false for the same compared objects. And fifth point in the contract, for any non-null reference x, x equals null should return false. This is the contract. Now we will see in the contract here in the getClass, we explained that this line can be changed, can be modified and altered to other things. When do I compare two instances, two objects using instanceof, and when do I compare them using getClass? And this is also very important. So, instanceof is an operator, not a function, while getClass is a method of the object class. See here, getClass is a method inside the object class, and it returns the runtime class of this object. It returns something instance of the class with the Joker parameter. So, instanceof operator compares an object to a specified type. Can use it to test if an object is instance of a class, an instance of a subclass, or an instance of a class that implements a particular interface. So all these three cases return true if you compare an object with a type that the class of this object implements with a type that is instance of it, a class, or a subclass of its actual class. So there are two different scenarios where inside the equal you have to write if they have, when do you say if this dot get class different than other than get class, and when do you say if other object instance of, for example, equals, because we are inside the class equals. When to choose and what to choose. If the answer is here, if subclasses can have their own notion of equality, for example, a manager to be equal to a manager, this is special for managers and not like employees. For example, you have to compare bonuses. Then they have to have the field bonus. Then we must be sure that they have the same class, okay? Then symmetry requirement forces you to use the getClass test, okay? Because you cannot say if they are instance of employees, then compare the bonus This would not be possible because maybe they don't have a bonus field. If the notion of equality is fixed in superclass, okay, so if you don't intend to use special features for subclasses in order to decide whether two objects are equals, then you use the instance of test and allow objects of different subclasses to be equal to another. Then in this case, you choose equals, and we will do exercises about this problem, this case. About both cases, we will do applications. We will be very precise in applications, okay, to decide which case. This depends on the problem, on the context, on the condition. If the notion of equality is fixed in superclass, then you can compare a secretary with a manager, a student with an employee, for example. So you fix the equality in the superclass. What does it mean? You fix in the superclass. It means the equals will become final in the superclass. You cannot override it anymore. Then you use instance of in order to permit to be all return true when they are instance of employee. For example, this is the superclass employee. And test and allow objects of different subclasses to be equal to other. Okay, this is one condition. You use in this case what? Instance of. If you don't want the subclasses to be equals to other objects from different subclass to be equal to one another, you use getClass. This is a very important detail. Take an example. If you want to allow that E equals M returns true sometimes, where E is an object, employee object, and M is a manager object, or an object variable that references a manager object, and E is an object variable that references an employee object, then you are letting for the symmetry rule, even if they return true or if they return false, if they return something and don't make an exception, that means you must permit the call, the symmetry call, the m dot equals e, to return the same thing and not to generate an exception. So this means you have to compare them using the instance of operator and not the class getClass operator, because if you compare the implementation here using the getClass implementer, you will not be adherent to the symmetry rule. One will generate a class cast exception and the other will give either true or false answer. So, for example, if you use the employee ID for equality testing, and this will be true for all the hierarchy of the employee, then use the instance of test and declare employee.equals to be final. Let us see some coding example. Here inside employee. Okay, let me copy and paste this equals test to be equal test 2 in order to change it. Okay, this is equals of employee. It uses getClass. Okay, and this is manager equals. It uses super.equals. And let's take equal test 2. And suppose that we want to compare an employee with a manager. Okay, LS1 with Carl, where we want, okay, so, LS1, okay, let me pause. This is Carl. Okay, this is boss. And then let me delete all those instructions. We are getting confused. And then let me system.out.println Alice1 equals boss, and then the value of Alice1 dot equals boss. What do you think this will give me? Okay, Alice1 equals boss false, which is very correct. Okay, and here if I reverse the order, I must get also false. Boss with Alice1. I want to know what is the answer if I compare boss with Alice1. And it will give me also false. So this doesn't break the symmetry rule. They are not equal one to another. If I take copy paste of the values here, okay, and I compare them, they will still be not equal because I am deciding in the employee class to compare the getClass. Okay, the getClass is a reflection method that will give me that for Alice1 the getClass is employee, for both the getClass is manager, so they are different getClasses. So this is the condition that leads to false. If this is an option, I only compare managers with managers and employees with employees. So for example, if I take this code here and I paste it here and I name this is boss2, okay, boss2. So this is exactly a duplicated object, two different objects but with the same state. And let me check this. I say boss, is it equal to boss2? Run. Of course it will give me true. So this is one option. The other option is to consider that they are equal if they have the same instance, if they have the same if they are instance both of employee. So what shall I do? So this is very delicate here. The other option is that I want to allow the comparison of uh, an employee with a manager, and to allow that it would say yes, they are equal Alice1 to boss. So if I do a semi job, it will lead to disrespect to the contract of equals. Suppose I go to the equals class and I go and I want to change the get class and to write if other, if not other dot object instance of employee return false. Okay, and suppose I need one additional parenthesis here, and the instance of is one word. Okay, if I do this job, this is incomplete, this is false. Look what will happen. I go to equals test2, I save everything and then I run. I proceed. Look what has happened. Alice1 equals to both is true because they have the same name, the same, where is it? Alice1 equals test2. Okay, Alice1 equals to both, it's true. But when I wanted to compare both with Alice2, okay, with Alice1, it yields to what? Which exception? Class cast exception. Where? In the line 27 inside the class manager. Why? Because when I tried to cast to manager, which is Alice1, I tried to cast it to manager in the second call. Look here. This is to delete this one. When I reversed, for the sake of symmetry, I wanted to check if the inverse is also true. Alice1 here is the other object, and inside the line 27, I wanted to cast it to manager without knowing that this is a manager, because all what I have done inside the employees class is that to ask, is it an employee? I didn't ask, is it a manager? So this is very, very wrong. I have to choose one of those solutions, not a cocktail of those two solutions. Either I choose getClass, or I take it fixed and I choose instanceof. So fixed with instanceof. This means, what shall I do? How shall I correct? I shall, when I choose to compare using instanceof, I have to go to manager and cancel this equals. Completely cancel this equals. So I will cancel it, delete, and I will go to employee again, and to make sure nobody will ever again in the subclasses of employee try to override this equals. So this is the final equals for employee and all is descendant. And now if I go to equals test2 and I try it, I will get that Alice1 is equal to boss and boss is equal to Alice1, and this is the symmetry. You can return true, you can return false, you can do whatever you want, but it must be symmetric among all the 5 other properties. So this is very important. What is the recipe for writing the perfect equals? 1. Name explicit parameter other object. Okay, you can name it whatever you want, but name it other object. Okay, listen to us. And later you need to cast it to the variable called other. It will be short. Second, test whether this is identical to other object. Okay, test if this equals other object, return true, of course. Third, test whether other object is null. You must retain this by heart. You must do this quickly. So third, test whether other object is null, or if so, return false. Fourth, compare the classes of this and other object, either by if getClass or by if not other object instance of class name. Okay? And if they are not, return false, of course. 5. Cast other object to the variable of type class type. So class name other equal class name casting other object. And then compare the fields using equal for primitive types, equals for object fields, or objects dot equals for to prevent null dereferencing, and use arrays dot equals if you are comparing fields of type arrays. And here we said it here. Okay. So this is it. If you redefine equals in a subclass, include a call to what? To super.equals. This is the last and condition for the perfect equals. Now find the mistake in this equals. What do you think? There is one. What is this mistake? There is a very big mistake because here inside class employee you declare public boolean equals employee other, and this is not overriding, because overriding you must have the same function name, the method name, and the same parameters, and this is not the same parameters as in equals. Look, equals, it takes a parameter of type object and not a parameter of type employee. So this is a big mistake. In order to avoid it, write always at override before your equals definition. That way the compiler will help you and will tell you are not overriding. Attention. Now we will talk about the method hashCode and then the method toString, and we will finish the object section. Note that in the equals documentation there is a very important sentence here at the end that says, note that it is generally necessary to override the hashCode method whenever this method is overridden. So whenever you override equals, you have to override hashCode. They are both methods for objects and they have both default implementation. If you change the implementation of one, you must change the implementation of the other so that they stay together. As to maintain the general contract for the hashCode method, which states what? That equals object must have equals hashcodes. Okay, so now we will see what is a hashcode. But the contract of hashcode says that if two objects are equals, they have the same hashcode. So let us go and see what is a hashcode. A hashcode is an integer that is derived from an object. For example, the method name is called hashcode. It has no parameters, it returns an integer, and of course it is a public method. It is defined in the class object, and every object has a default hashcode. Every one, it has a default implementation, which is derived from the object's memory address. For example, the string hello, it will have the hashcode 69609650. The string array will have the hashcode 6949644448, etc. and etc. So example, if you take a string hash OK, a string builder SB equal new string builder of S, we all know, I remind you that string is an immutable class, while string builder is a mutable class. You use the string builder type in order to construct strings, to concatenate strings, for strings that change state frequently, because if you use string type for this string, it will be very slow. Okay, if you say s.hashcode plus sb.hashcode, you will get the hashcode of s, the hashcode of sb. If you create t new string OK, even if it is a new object in the memory, in fact it will have the same hashcode, because the hashcode is based on the state and not on the memory address. Why? Because inside the class string, the method hashcode is overridden. Okay, the default implementation of the method hashcode is to print the memory address, but you can override. Okay, and what does the Java builders do? The Java builders redefine, override the method hashcode for strings so that two equal strings will have the same hashcode, and this is very important. And then if you say string builder tb equal new string builder t, just like sb, but it will not have the same hashcode even if it has the same content. Why? Because string inside strings hashcode derived from their contents, but there is no hashcode method that has been defined explicitly for the string builder class This means the string builder class inherits her hashcode from the hashcode of object as default implementation. You can redefine hashcode. For objects that users might insert into a hash table, it should return an integer. Okay, the hash code is used especially into hash table, especially into when we use the hash sets, when we use the hash maps, and those are collections. Those are in the part of collection. When we arrive at this lesson, I will explain for you in detail why hash code is very, very, very important. But now you must know that every time you define equals, you have a certain concept about equals. For example, for you, equals depends on the same name and the same salary, regardless of the hire day for employees. Okay, you must redefine also, you must override also hash code to be based only on the name and the salary, regardless of the hire day. If you don't do this, you are breaking the contract of equals and hash code. And if there is something important in Java, it is equals and hash code. For example, how do I define hash code? Public int hash code, no parameters, and here you return 7 times name plus 11 times double. This is a primitive way to define hash code. There is more advanced way. Plus 13 times higher day. Oh, and remember with me here, there are hash codes, methods for all the fields, even if it is a primitive field. There is the wrapper class double, which wraps the primitive field of type double salary, and it has its own hash code. There is a hash code for the class local date, and there is a hash code definition for the class name, because hash code is for the class object, so it is inherited in all the classes. Even for the classes that don't override it, it exists already. So what are we doing here? We are multiplying by prime numbers. 7, 11, let me change the color of the pointer. Pointer options, pen color, blue. So I am multiplying by 7, then I multiply the salary by the hash code of the salary by 11, then I add it, then I multiply the hash code of the higher day by 13. Those are prime numbers. Why? In order to scatter the hash code, in order not to have the same hash code from two different states. Okay, now we will say that equals and hash code must be compatible, and I showed you this in the documentation. Equals objects must have equal hash codes. If x dot equals y is true, then you have x dot hash code must give you the same answer as y dot hash code. The inverse is not necessarily, however, it helps a lot. If employee dot equals compares ID, then inside hash code you need to hash only ID. Okay, suppose employee dot equals compares only the employee ID, you must cancel all and put here the ID of the employee. If the equals compares only the salary, you must cancel all from the hash code and leave only the salary. Whatever field is important to you inside equals that you compare, you must use here in the hash code. This is very important. And for array type fields, you can use the method arrays.hashcode, which is, as I already explained about objects, arrays is a utility class that has a static hash code. So let us see it. Arrays.hashcode. Okay. As As you can notice, this is a static method because inside this utility class, everything is a static method that takes the array as parameter. Okay, a static method has no implicit parameter, so in order to hash a table, you must give it as an explicit parameter. A better yet method to implement hashcode since Java 1.7 is to use the hash method inside the object's utility class. It is an easy method that will do the job for you. You just pass to it an arbitrary number of parameters which will be part of your hash code method, and of course you will choose the same instance field you used to compare in equals method. So here you pass name, salary, and hire day. And in the subclass method, of course, you will use the super.hashCode as one parameter of the objects.hash method. So you will use it and you will pass the additional parameter because this version of hashcode must match the version of equals in which we have allowed overriding of equals. Let us see in the code here. This is employee class. Okay, inside employee class we have the equals. Public click again. And here we have allowed the getClass to be compared. Okay, so we have allowed that the manager class the manager class. Here inside the manager class we are overriding equals and calling super.equals. So the same thing must go for hashcode. We can override hashcode and call super.hashcode. So this is essential. Whenever you override equals, you override hashcode. And inside equals you use the field bonus. So inside hashcode you use the field bonus. To ensure that you use the hashcode of the super method, you pass it as a parameter to the hash function of the object utility class. Okay, so this is how we define equals and hashcode, and we call to the equals test. As you can see, Alice1 must be equal to Alice3. Okay, and so if we print the Alice1 hashcode and the Alice3 hashcode, we must have the same. Let us run and try. Alice1 is equal to Alice3 and Alice1 hashcode equal minus 8888 etc., which is the same as Alice3 hashcode. This is essential. The rest of the test is to demonstrate the toString method, which is also a method for the object class. So let's explain this method. So this is the easiest among object methods, and you all know that it is a public called toString methods. Let's see it here in the objects methods. Okay, we are not even in the object method, so let's go back. Okay, method toString. This is a toString method. It takes nothing, it returns a string, it is a public method, and let us see it. Public string toString returns a string representation of the object. In general, the toString method returns a string textually represents the object. Okay, and there is a guideline. Okay, in other words, this method returns a string equals to the value of getClass.getName plus add plus integer to hex string of hashcode. This is the default implementation. We all know that the source code of Java is open, so you can get it and see that this is written like this. So this is the default implementation, and you must inspire from this implementation. For example, the class point inspire from this implementation in order to override and keep the getClass.getName method and then square brackets, and then comma separated pairs of field name, equal sign, and field value. Field name, field value separated by equal sign. If we want to do like this, we will print public string to string, return employee name equal plus name, comma, salary equal plus salary, comma, hire day equal plus hire day. Even if hire day is not a string, it has a toString method, so it will be invoked implicitly. And then you close the square brackets. Instead of writing employee, this toString method can be inherited by the manager class. So if it was not overridden inside the manager class, it will appear employee. This is not beautiful. So you have to write getClass.getName. This way, inside the employee class, it will be manager. Inside the employee class, it will be employee. Inside the manager class, it will be manager. And of course, just like we did with the hashCode with the equals, from inside the manager class, you only have to call the super method and then add to it the additional features, name and value separated by the equal sign. This way you have a square bracket every time you have a subclass. Okay? The toString method is also very important whenever an object is concatenated, just like here, plus bonus, plus hire day, plus salary, plus name. Whenever an object is concatenated with a string by a plus operator, the compiler invokes the toString منه لحال. So, for example, point p equal new point, string method, the current position is plus p, it means is plus p dot toString. If you call system.out.println x, it means x dot toString. Object class define toString method to print class name and hashcode of the object by default. Okay, but you can change as we learned. For arrays inherit the toString from the object, which is yield to square brackets or sign at and then the hashcode. You can we have a remedy inside the class, the array, the utility class arrays. You can invoke if you have a string, if you have an array. Suppose the array name is lucky number int array name. Even if this is a primitive type array, you can print it using arrays.toString, and of course, again, everything inside the utility class have an explicit parameter, because no implicit parameters for the static toString which is inside the arrays utility class. So to print multidimensional arrays, if you have an array inside which you have another array and so on layers, you have to use the other static toString method, which is called arrays.deepToString. And this is you can enjoy consulting the documentation for the class object, for the class objects, arrays, and what else? And for the class, because it has the getName method. Okay, that was our first part of the chapter Inheritance. See you next with the rest of the sections.